back up. So we've got this unit circle, and got this point, x, y, and that point spins around the circle, creating a y and an x and an angle. And we're going to change all of our O's and H's and A's into y's and r's and x's. Does that pretty much sum up what we just said? Pretty much sums up what we just said. Okay, so here are all of our changes to sines, cosines, and tangents in the reciprocal function. Alrighty. So let's go take a look at some of this action here. We're going to take a look at all 6 trig functions, depending on where I'm at as I spin around this quadrant here. Now, these particular points here actually aren't points that would be on this, what we call the unit circle, right? Radius of 1. We're doing something different with this next example here, but the concept should still apply. What we're gonna do is based on these points here. For example, 1, we're gonna put our terminal ray at a location based off of a coordinate, and from there we're gonna create a triangle. So my thinking process is to always picture the triangle if they exist, because the triangle helps me know what my O's, H's, A's, or my Y, R, X's are going to be. So we want to find all the trig functions that satisfy the location of this -5, -3. So the very first thing we should probably do is let's put that point somewhere. Well, not somewhere. Exactly where it's going to be. What quadrant is -5, -3? Good. So the bottom one's over here. -5, -3. Let's just say it's right there. And when we did this, we created a triangle. And that triangle has a hypotenuse like so. It's got an x value right there. And it has a y value of this. Where's the angle? Where's theta right now? Where's the little angle in the triangle hanging out? I love it here. Yeah, it's right. It's right here. It's always going to be, when we create these triangles, that theta, which we're going to talk about, is known as a reference angle. That little angle is always going to be coming from the x-axis, never from the y-axis, always from the x. It turns from the x. So there's my little angle. All right. Now, in this triangle, kind of going back to yesterday and then making that transition to y's and x's and r's and stuff. If that's my angle theta, is the red line or the blue line my opposite side? The blue is my opposite side. And the blue, thinking about x's, y's, and r's, what is the blue line? Is that a y value, an x value, an r value? It's a y value. It's an up-down line, which is a y value. All right, so we get that. Then the red line is the what of this angle theta? Which part? It's the x, which is our adjacent, yeah. Now, technically, they're negative, right? It's a negative x, negative y, -5, -3. So there's the triangle that we create. What are we going to do to find that? Something. What do we do to find the missing third side of the triangle? Pythagorean? Pythagorean theorem. That's a new guy. He's a new Greek guy. He's quite thinking. So, yeah, we're going to use good old P theorem, and that would mean we've got a -5. The negative is really not important here. If I wanted to find r, remember I get a squared b squared equals c squared, or in this case, r is going to equal to the square root of -5 squared plus -3 squared. What is this? This is also, besides being Pythagorean's theorem, it's also the what formula? Somebody whispered it back there. The distance formula there. So the square root of 25 plus 9. Or square root of 34. Now, can I simplify radically the square root of 34? Can I break that down? No, we're going to leave it like that. We're going to leave this as the square root of 34 because I can't radically simplify that. All right, good deal. So we now know what the hypotenuse is. The r is equal to the square root of a 34. All right. In order for me to answer the question of what are all the trig values, I need to have all three parts of that triangle. So the purpose of drawing it in the quadrant and then finding the missing part is so that I can look at what are the values of this thing. All right, let's do it. Let's find them. Let's start with sine. Sine of this angle theta that we've got hanging out down there is equal to a y over an r. And in this case, my y is a negative 3. Whoops, notice I wrote it as a 3, not a negative 3. So my y is a negative 3, and my r is a root 34. Okay, question for you. Can r ever be negative? Is that possible? Why not? Two reasons why. What's one reason why r is never negative? Somebody said it. Distance, it's distance, and distance is absolute value. What's the other reason? It has to do with this. Circle. The radiuses of circle ever, are they ever negative? No. Has to do with the distance thing again. So that's the two reasons. Yes, Dave?
So wouldn't the 2x and y values technically be positive?
Would the 2x, you mean specifically where we're at?
No, just the 3, 5. That's there.
Okay, if I am referring to actually distance or length of this triangle, if I'm going to ignore the fact that it's in the third quadrant, then yes, it is actually just a 5 and just a 3. But we're using the actual location based on the coordinate to draw the triangle. Later on, these negatives are actually going to come in handy for us when we start talking about what are the values of sine, cosine, tangent, secant, cosecant, cotangents in all four quadrants. So this negative stuff will come into play later. So that's why we're going to leave it labeled like this. But yes, those distances are really just 5, just 3. It happens that they're going in the negative x direction and the negative y direction. All right, so there would be our value of sine. Now, can we leave an answer that has a denominator with a... No, we got to rationalize this. So remember how we rationalize? Yeah, multiply by square root of 34. So really what the sine is it's negative 3 root 34 over 34. There's the value of sine. All right, let's do cosine. What's cosine going to be based on this? Cosine, again, is my x over my r. Negative 5 over the root 34. That put us there. Negative 5, square root 34, multiply both sides, and I get negative 5 root 34. When I say both sides, I'm meaning top and bottom. So there's your cosine value. Tangent. Tangent of an angle theta here in this triangle again. What's my tangent going to be? What's my what over what? Trying to think new world. Y over x. Tangent is y over x. And if that's the case, then that means I have negative 5. No, I don't. I have negative 3 over negative 5, which just equals 3/5. And then we keep going. So, but here's the beauty about reciprocal functions. Once you know those 3, what do you do to find the other 3? I flip them. That's it. I just flip them. So, thinking about cosecant, which is the reciprocal of sine. Cosecant theta would be, let's flip the original y over r. So it was a negative 3 over square root of 34. Now it's a square root of 34 over 3. And it's still negative. Does it matter really where the negative goes in a fraction if it's in the bottom? No. I can just write it as negative of root 34 over 3. So I got this. And then cosine. What's the reciprocal cosine? Secant, exactly. Secant is the reciprocal of cosine. So we're going to flip that one over. Go back to your original cosine. X over r, negative 5 over root 34. Flip it. Root 34 over 5. That's got a negative value. So there's our secant. And then cotangent, the reciprocal of tangent. Flip it. What's 3/5? Now it becomes a 5/3. So this is the beginnings of, if we just keep building, kind of layering here, it's the beginnings of taking a look at what happens in all 4 quadrants. So in quadrant 3, what is your observation about the value of sine? What happens in quadrant 3 for sines? Based on just this problem right now. When I say value, I mean the SIGN of that sign. We know what SIGN means. Okay, so what's the sign of sine in quadrant 3? It's negative. The sign of sine is negative. It's negative in quadrant 3. What is cosine in quadrant 3? It is also negative. What is tangent in quadrant 3? And then cosecant is related to sine, so if sine was negative, so is cosecant. And if sine or cosine and secant are related, so if cosine is negative, so is secant. And tangent and cotangent are related, so if tangent is positive, so is cotangent. So this, pay attention to this, because actually it comes into play a little later. Yes?
How do you know to use sine for like y over r?
Okay, good question. How do I know to use sine for y over r? Based on where our triangle is and based on the angle that we have. Remember, the sine is an opposite over the hypotenuse, right? So look across from the angle. What do we have? What's my opposite of y? Y. My opposite is y. And the hypotenuse has now been written as a r. So that's why sine is y over r. It's still opposite over hypotenuse. You just changed the name. Opposite is a y and a hypotenuse.
Okay, but how do you know to use from sine to cosine? How do you notice where to go from sine?
I kind of think that you're thinking of the problems we were just doing. Maybe here's the triangle, find the missing part thing. And that's not this. This is just simply using the parts that I have and figuring out what all of the ratios would be based on those parts. I'm not finding anything here except what the ratios are for all 6 trigonometry. Okay? All right. Okay, can we, let's see, we're out here 10:30, right?
Yeah.
Okay, I think maybe we're going to come back. We have some time to come back to these, but let's skip over here to this next one. Kind of thinking along the same lines now. Was there a hand? Was that a hand? See, you're right down there, my friend. Really? You're not playing your phone or anything? Okay. It's usually a telltale sign when a student's looking down, smiling at their crotch. Usually a sign of the phone. Usually just don't smile. Oh, recording. All right. Oh well. So we got a 4th quadrant angle.
We get a little treat in the video.
That's okay. So we got a 4th quadrant angle, and it says the sine of this angle is producing that ratio. And now we want to go find the cosine. So just like the last problem, we had what's it called? A point that was given to us that helped us figure out where we are. Well, actually, we've been told now where we are. We're in the 4th quadrant, and we're in the 4th quadrant with a sign that produces this ratio. So remember that it's a y over r right now, which means I know what my y is. It's negative 5. And I know what my r is. It's a 13. All right, so we go ahead, we put ourselves in quadrant 4. Let's draw a triangle down here. There's my triangle, quadrant 4. So my angle talking about a reference angle, but for right now, we're just going to say, there's the angle that I've got. Reality is that when it says I've got this angle theta, really what has happened is it's giving me this. That is the theta that produces this guy. But we're going to refer to it as reference angle and use this alpha symbol. But for right now, we're just going to say, all right, there's my angle that we're looking at. Creates this triangle. And we know that I have that y value and I have that r value. So, do we have all the parts of our triangle that we need? No, we're missing the x. So we got to find the x. We've got to find this part. So how do I do that? On a right triangle when I miss a leg. How do I find the leg when I know the other parts? I still use P theorem, right? I still use Pythagorean, but this time you're not looking for c squared. Now you're looking for an a or a b squared. So this is now what I'm going to use. When I'm looking for a leg, Pythagoreans gets to become c squared minus the other leg squared. And if I did that, I have the square root of 169 minus 25, or the square root of 144, which is just 12. So I know x is equal to 12. And then once I have all those three sides of my triangle, then I could find all of the other trig functions. But this one is just asking me to find cosine. So what's the cosine of this angle? X over r, so it's going to be what? 12 over 13. Okay, now look at the SIGN again of where we are for cosine. What is it? It's positive now. Quadrant 3, it was negative. Quadrant 4 becomes positive. I wonder why it's doing that. Anyone see anything why it might be positive on the right side but negative on the left side? No connections yet? What? Oh, it is reflecting. That is true. It is reflecting. The triangle's kind of flipping over. Yes?
Which side is the y-axis?
Close. Not the y-axis. The x-axis. Very good. It's because if on the right-hand side, my x's are positive. On the left-hand side, my x's are negative. So that's why cosine is positive on the right and negative on the left, because cosine measures x. Cosine takes a look at x values. Sine takes a look at y values. So that's why sine was negative in quadrant 3. What do you think sine is in quadrant 4? Negative again, because it's still below in the negative y world. So yeah, there we go. We're going to start making these connections. All right, what questions so far? I know we just kind of hit one example and then we're moving on. Anything that we need to... Yes? Oh, that's a good question. What does tangent correlate with? Does anyone remember what tangent correlates? What's tangent? Good. Let's talk about y, r's, and x's. You're right. Tangent of some angle theta is equal to an opposite over adjacent. But in our world, we're now looking at what over what? Y over close. X. Yeah. Remember, O is like our Y. So Sam, Y over X is a little different, right? I just can't look at quadrants and see, oh, Y over X. Well, I kind of can. Like, let's look at quadrant 4. What's the value of Y in quadrant 4? Positive or negative? What's the value of X in quadrant 4? So if a Y over X would be a what? Quadrant 4 for 10. Negative. Exactly. All right, you guys are kind of jumping ahead there, but that's okay. All right, you guys want to try that one on your own? Real quick? Is that enough? And try this real quick. Draw where I'm at. Third quadrant. Triangle here. Go back to the x-axis. There's my angle that I'm interested in that produces this triangle ratio. It's a cosine given to me, which means it's an x over r. So there's my r, there's my x. I need to find y. So to find y, Pythagorean theorem. 5 squared minus negative 3 squared. And I get square root of 16 or 4. So my y is a 4. But it's actually a what? It's a negative 4. It's a negative 4. Yes, Tanner?
Why did you grab the leftovers?
Okay, so hey, can you guys just say what? What was the question?
Why did you grab the leftovers? Like mine.
Oh, you mean why didn't I graph it like a 0.3 negative? Okay, this isn't a point. So when I have this cosine sine tangent ratio, they are a fraction. And that fraction is based off of x's, y's, and r's. So cosine is an x over an r. So that's how I set this up, like that. It's different than what we did before where I said, I'm going through 0.35. That's completely different.
So how did you set up your triangle before you?
So how did I set my triangle up? First of all, this was the big giveaway. Quadrant 3. I drew from my vertex some terminal ray in quadrant 3. And you take your point from that terminal ray and always go back to the x-axis. And that angle that you drew to create that terminal ray is what I use to make my triangle. So my triangle is made up of that x value, and that y value, and that r value. Is that what you're asking?
Yeah. How did you know what angle?
Okay, the angle that I make for this triangle always comes from the x-axis. So wherever I am on the x-axis, that's my angle. Yeah, we don't care what angle it is right now. Yeah, I'm just drawing a generic triangle. We will eventually care what angle that is. And we can find out what angle that actually is, but we're not worried about that right now. All right, so then, if that's the case, and I know that sine is a y over an r, we just found our y is a negative 4, our r doesn't change, so the value of sine would be negative 4 too. Who had that? Just really that many of you? Gotta be negative. Exactly. Light mode. All right. Okay, now here. Are you okay on that last example? Any questions on that last one? Yes, you're good? Okay, so on this one, silence, people. Thank you. Now we get to actually use the calculator again. Notice all of those are reciprocal functions. This is just a little practice from yesterday for reciprocal functions. So we're looking for the approximate trig values for these given angles. And remember that there is no trig reciprocal function probably in your calculator, unless you have one of the big guys. So, secant. What function is a secant the reciprocal of? Good. Cosine. How do we know that? Yeah, how do we know that? The way I remember it, and you can think this is just kind of lame. I don't care. But here's how I remember it. So, sine, cosine. The reciprocal functions start with the letter well, it starts with the letter you would think this is not making sense. So sine, starts with a C instead of an S. And then C, cosine, starts with an S instead of a C. Very good. Thank you, Bobby, for clarifying that. And then tangent, that's easy, just cotangent. So that's how I remember it. And you guys can decide if that makes any sense or if I'm completely off my rocker for that one. You like that? We're going with option number 2. So this secant of 221.5 degrees. So I can simply do a 1 over a cosine of 221.5 degrees. And then making sure I'm in degree mode, putting it in the calculator carefully. 1 divide cosine, 221.5, close the parenthesis, although I don't think you need to necessarily. And then you're going to tell me what you get. Negative 1.33. Okay? We got confirmation on that from a few people, negative 1.33. So if you're not in degree mode, you have something different. If you're in degree mode, you're going to get that. All right? Does that make sense? Okay, so how does this relate to what we were just doing? What quadrant is that in?
4.
Don't say either 3 or 4. It is in one quadrant. Which one is 221? It's in quadrant 3. Yeah, you guys are going to get familiar with your angles and stuff. Remember, this is 0. There's 90, 180, 360. So I'm over here. Oh, no, I'm not. I'm over here. Oh. Yes, why did I write 260? Oh, man, this is just one of those days. All right, so 221 is right there. That is my angle that produced this triangle. So I'm in quadrant 3. And in quadrant 3, based on what we've done so far, what are cosines in quadrant 3? S-I-G-N dot. Negative, very good. And look what our answer is. Our answer is also negative because cosines and secants are related to one another. Isn't this so fantastic? It makes you want to go buy a puppy. Okay. Okay. All right. One other last bit. I know, again, we're just kind of highlighting here, but one other last bit. All of these calculatorable problems, right? 1 over tan of 7.33. 1 over sine of changing my mode, 1.7. Now I'll find my answer. So this is kind of what we're trying to get to, though. So we can go on to section 4 and talk about the exact values. All sine, cosine, or sine, cosecants, tangent, cotangents, cosecants, and secants. And the reason we're highlighting these letters in red is because this acronym is what I use to remember the value of the SIGN of each of these functions in their respective quadrants. So what's happening with sine, cosine, tangents, cotangents, secants, cosecants in quadrant 1? Well, because x's and y's are all positive there, they are all positive. That's what that means. A means all the trig functions are positive. So this acronym of ASTC just tells me I have positive values for my trig function. Whatever that trig function might be. Some of them are going to be positive, some of them are going to be negative, except for the case of quadrant 1 where they're all positive. Now, the acronym, there is an acronym floating around that says ASTC can be remembered by all students taking calculus, but I prefer the all support the covers acronym. And I should. That'd be fun. So that's what it can do. So in quadrant 2, sine and cosecant are the only things that are positive. Cosines, secants, tangents, cotangents, they are negative. Quadrant 3, the only thing positive is tangent, cotangent, and so on and so on. So remember this ASTC thing, and we use it a lot. So we got to get familiar with it. Helps me know where I'm going to be positive. And so I can answer then a question or questions regarding something like, oh, maybe people are still writing that down. Somebody still writing that down? Sorry. So then let's do a few of these. Just a few of us. Maybe we'll break up. A couple of you guys can tackle A. How about this little crew? These first 2 rows, you guys are my A. You guys find the answer for A. You guys find B. So you guys, first 3 rows here. C, D. What are the signs? I don't care what the answer is. I just want to know, is it positive or negative in these spots? That's what I'm looking for. So there we go. Let's see if we can do it. So this is going to require you to change your You got to convert, right? If you're not familiar with your conversion, it's going to tell you to convert your angles so you know where you are. And based on where you are, you're going to answer the question, is it positive, is it negative, or is it maybe even 0? Oh. All right. So let's see. The A people. It's negative 2 pi over 3 folks. Can you guys help us remember where we are angle-wise? Thinking of degrees, because probably most of us are more familiar with degrees. What is 2 pi over 3 as a degree? How do we convert it? What formula do I use? What's my conversion factor? That's right, what's that? 180 over pi, very good. So if I took negative 2 pi over 3 and I multiplied it by 180 over pi, I'm going to get negative 120. Negative 120 degrees. Which quadrant is negative 120 in? Good. It's in the third quadrant. All right, now we can answer the question. Sine in third quadrant. All supports covers. What is it? Look at quadrant 3, sine. What is it? It's negative. So this would be a negative value for a sine of negative 120. All right, how about a cosine of negative 120? Remember, negative 120. We're quadrant 3 right now. What's cosine? Look at the act. So we're over here, right there. Cosine is. If you don't see cosine written there, that means it's got to be negative. Things written here are the positive values only.
Oh, okay.
Yeah. That helps. Yeah, that's why I said over here. These are just positive. I'm sorry if that didn't make sense. Yeah. So everything positive, just sine and cosecant, just tangent and cotangent, just cosine and secant. That helps. That makes it so much easier. Why didn't I say that before? All right. Sorry about that. So going along here, cosine, negative. What's tangent going to be? Positive. See how easy this is now. And then how about cosecant? Negative. Oh, man. How about secant? Negative and... All right. Is that hard to do? All right, now who had this one? Who had the B group? Is that you guys? This is a toughie. Do you know this one, Austin? 3 pi. Where are you with 3 pi? Quadrant 1?
Yeah.
Let's see. 3 pi, let's convert it. 180 over pi gives me 540 degrees, which means I've gone around the circle 1 time, and I've added another 180. I'm right there. Is that a quadrant? That's on an axis. So here's where we get back to quadrantal angles, and we've run out of time, and we'll have to do this later. All right. I'll just YouTube what we've got here. You guys can figure it out.